Hi, I'm Nishra and I'm from Group 15. We have Project 5, which is continuous ASL recognition. So we need to develop a system to recognize gestures done in American Sign Language. So the project is divided into a three-phase. The first phase was data collection, in which I went to Impact Lab and we used the biosensors to collect the data. For that, we learned the American Sign Language. We researched about it. We learned how to perform a different gestures in that, like how to do a different actions, like if how to do a different perform a different words, and how to do a gestures for a different sentence in this language. And then we video recorded the data for the gestures, and we also collected the CSV for all these gestures. Since each word and sentence is recorded as a 15 hertz, so our CSV should contain 45 lines. So for the part phase 2 of the project, which is to implement the machine learning algorithm, I pre-process the training data. For that I drop extra 4 columns for all this file, and for that I have write this function in which I have taken all the files and dropped all those extra column which doesn't contain any value or null value. And then I have converted each CSV. I have checked that how many CSV doesn't have the rows 45 or greater than rows 45, and in this part I have converted the CSV to 45 rows. And here I have flattened the rows into a single row of file, and I have, after flattening the CSV into a single row of file, I have combining all those CSV into a single file to make one trained CSV. And now I'll show you the two machine learning algorithm which I implemented. The first is logistic regression, that predicts the probability of instances belonging to a class, which can be a 0 or a 1. And for that I have imported the module from sklearn for logistic regression, and the accuracy for this was 15.37, as you can see here. And the second algorithm, machine learning classifier algorithm, which I used, was a Gaussian naive Bayes method. Is a set of supervised learning algorithm based on applying a Bayes theorem assumption of independent between every feature. Gaussian naive Bayes implements Gaussian. So this is the function which implements the Gaussian naive Bayes for classification. And the accuracy for this classification algorithm was 22.95. And I also tried to implement the AdaBoost and SVM algorithm to see the accuracy, and for SVM the accuracy was 5.19, and for AdaBoost the accuracy was 9.18. And I have also tried to implement these machine learning algorithms using a PCA. So for PCA I used 150 features instead of using a 349 features, and then I'll show you the accuracy of a different classifier algorithm I got. For Gaussian I got 20.57 after using PCA. For logistic regression I got 6.79. For decision tree I got 5.59. For nearest neighbor I got 5.90, and for SVM and random forest I got 5.9 and 8.38. And this is the graph which is showing the different models we have used to classify the gestures and the accuracy according to different models that we have achieved.
Hi, I'm Samur Shah from Group 15 and I'm implementing project number 5. I did the first two tasks, that is collecting Maya sensor data for all the 20 words and 5 sentences. Here I'm describing the task, that is implementation of k nearest neighbors to classify the words. The k-nearest neighbor is an algorithm that takes in the testing data point and it compares with every data point in the training set, finds the k-nearest neighbors to this data point. Then it checks the class labels of these k-nearest neighbors, and the most frequently occurring neighbor is given as the output of the classifier. We are using the sklearn.neighbors package of the sklearn library and using the k-neighbors classifier class from it. For us, we have kept the value of k equal to 5. After testing the classifier, we get an accuracy of 14.57%. And I have written code to implement hidden Markov model. The hidden Markov model is used to segment these sentences, and I'll first explain the flow of the hidden Markov model. We first collect all the sentences from the folders, and we separate it into training instances and training labels. and testing instances and testing tables. We will use the training instances to train the hidden Markov model. So we start training the hidden Markov model. We are training it on sentence number 1, which is good night, father and cop. We consider resting period as a dot. So that makes 5 components for the sentence, and this will be a supervised training for the HMM. In the transition matrix, we are giving a probability of 1 for starting in the state called good night, and all the other states get a probability of 0. In state transition matrix, the probability of remaining in the same state is 0.9, and the probability of transitioning to the next state is 0.1. And that is what we're calculating here, and we're preparing the state transition matrix here. After that, we are training the conditional Gaussian distributions. It will be a multivariate Gaussian distribution comprising of 34 features for each CSV file. So that we are training from the samples. We already have the labeled instances. The labeled instances are coming from the previous step, which was manual segmentation. Once all the parameters of HMM are ready, we initialize the hidden Markov model, and we also record the time to initialize the hidden Markov model and train it. So now we are ready to do predictions on the sentences. First, we perform the predictions on the training set, and after that, we perform the predictions on test set. In predictions, the Markov model gives a best sequence of states corresponding to the given observations, and that is then passed to the decoder, which decodes. Just a minute. The decoder takes in a decoder where we say that good night is state number 1, father is state number 2, like that. So a decoder takes in the sequence of states and it filters out the repeating sequence of states and then decodes it into a sentence. The final output that we get after training is shown here. So in some instances you just predict a good night, while the actual sentence is good night, father and cop. In some instances you predict the perfect actual sentence.
Hi, I'm Hina Shah and I'm from group 15. Today I'm going to explain about all the 4 tasks I have done in the project. The first task was to collect the words. There were 20 words and each word was collected 10 times. For collection of the words, I went to the impact lab, and moreover from the words collected, 10 sentences were made, and these 10 sentences were collected 5 times. So these were my first 2 tasks. For the third task, as my group partner, as my project partner Nishra Pancha classified in the data, I have just done for the classification of the data. For the classification of data, I used decision tree classifier. In the decision tree classifier was imported from the sklearn tree. The reason I used decision tree classifier was that it uses data to approximate a sine wave curve with a set of if then else decision rules. The deeper the tree, the more complex the decision tree and the filter the model. Uh, After implementing the decision tree classifier, I got the accuracy to be around 15.157. As my fourth task, I have found the accuracy in the HMM model. To find the accuracy, we are using 15 sentences for the train set and 5 sentences for the test set. After predicting the sentences in the test set, if the prediction is correct, then we increment the count by 1, and if the prediction is not correct, then we don't increment the count, it remains the same. Say for example, over here the sentence is predicted to be correct, so we increment the prediction to by 1, and if the prediction is not correct, uh, then we don't increment any sentences, don't increment the count. Say suppose out of 5 test cases, 3 were predicted correctly, then our accuracy would be 3 divided by 5. Fine. So for the final model, our accuracy comes to be 60%. While we have also found the time taken to train the model. To calculate the time taken
train the model, we have just taken the timestamp at the beginning and the end of the model. Thank you.
Hello, my name is Achal Shah, and in our project for continuous ASL recognition, the first two tasks that I did was about the collection of data. The first task include the collection of data about the words, which were there are 20 words, and then the second task was to collect data about the 10 sentences. For each word, we have collected 20 different instances, and we have the CSV file and the video that we have. And similarly, for each sentence, we have collected 5 different instances with this. So we have the video and the CSV file for the same. So I have done the task of manual segmentation. In this, I have opened every video in a media player, which can show us our the time in milliseconds also. So first of all, I have played the video till a particular action is completed. Like I can see here, uh, that if the video is played over here, it is here the action gets completed at approximately 1.87. So I multiply the 1.87 with 15, because 15 is the frequency. 15 hertz is the frequency at which we have collected the data. So for that particular instances, we have our data as the first word, which is good night over here. So I have mentioned the different column in here with the name state, which I would be using for training. So here in the each state, I have mentioned 1 till 28. So for if we multiply 1.87 with 15, we would get approximately 28, and for that particular I think I have mentioned 1 as the state, so that we can know that this particular instances are for the first word. Likewise, I have defined the next states as 2, 3, 4, and the last state is defined as 0, which we can show as these as rest state. That is at the end, when our hands come to rest after all the words are completed. This is the rest state. So this part is the rest state, which is denoted as 0, and all other words are denoted by either 1, 2, 3, or 4, depending upon the number of words in the sentence.
After my project partner Nishta Punjabi has completed the pre-processing and the data cleaning part, I am using the random forest library for classifying the data. So I'm using random forest because it is a meta estimator, like it fits a number of decision tree classifiers on various subsamples of the data set, and it uses averaging to improve the predictive accuracy and control the overfitting. So this is how we import the random forest classifier, and by passing the arguments like max depth and random state, we use it for then we use it for training and testing the dataset. So with this, I got an accuracy of 16.57 on our dataset.